talk to Shane, it's even possible. Actually, this would be one of the very few countries that I think I would possibly want to move to, just because of the awesome food, the very good food you have here, and just it's peaceful. And I feel like this is one of the best places that I've visited so far. So again, thank you very much for coming. Thank you for the Citrix companions for setting this all up. Today we're going to have a pretty full schedule. It's going to be about 6 hours long. I want to make this something for you. I have a lot of presentation slides, but if you guys, if anywhere in between, you guys want to shift focus, I have no problem with doing that. But if we don't do that, I know we have set QA sessions in between each of my talks, so there's going to be answering any questions that you have. And also, we also have Citrix shirts here. So if you answer very good Q&A questions, I will decide to use one of these amazing Citrix shirts. Okay, so again, welcome. So what I'm going to repeat is what Kimmy's did before. I want to, for the agenda today, again, this is very open to you. What I want to cover today is, number one, what is CloudStack? So can I get a raise of hands here? Who has actually installed CloudStack today? Only very few people have installed CloudStack. Oh, okay, half of the business. Okay, that's good. How many of you have already, maybe not installed, but have seen the UI, the CloudStack, I think it's CloudStack 3.0 UI? About half of it. Okay, so today what I'll do is I'll give a demo with the UI as well, so that people that haven't seen it before can see what CloudStack does. So what I'm going to do is I'm going to talk about what CloudStack does today, kind of how we deploy the physical infrastructure, how we deploy CloudStack. Also, I want to go into the network, a little bit more into how we deal with networking. And then finally, for the morning, I want to talk about a little bit about the software architecture. And then Shane will go and give a presentation about what we believe the future of CloudStack architecture will be. And then in the second half of the day, again, I'm going to talk a little bit about how we customize UI for CloudStack. And especially I want to go into how you can construct API calls so that you can integrate your solution, whether it's PaaS, SaaS, or any other solution on top of CloudStack API. And then I want to go a little bit into how the UI plugin framework that we want to create for CloudStack so that it's easier for partners and for you guys to integrate against the CloudStack API. So of course we'll have a food and break in that. And then lastly, I really want to go into the reasons for why CloudStack is now an Apache competition project, and also how you contribute your code to the Apache repository. And I will hopefully have a little demo on showing you how to do that. Okay, so a little bit about myself. My name is Will Chan. I've been at Cloud.com, which is a company startup that Shane created a little over 3 years ago. I was a founding engineer. I was employee number 1 for the company. And I also was the engineering manager during the time at Cloud.com. It was acquired by Citrix in 2011, July. And from then on, I've been playing the role of the director of engineering there. So I manage the entire CloudStack team for Citrix, and going forward, it will be called Cloud Platform. I am also the PPMC member for Apache as well, so I help direct how the CloudStack project will evolve. And then I'm also a committer of the Apache CloudStack project as well. I haven't written code for over 1.5 years, but I used to be able to write code. And then Shane Leon, who also will be making a small presentation about the future of architecture. He is, basically the cloud engineering, and he was a founder of Cloud.com. And since the acquisition, he's actually the CTO for the cloud platforms group. Citrix. And the cloud platforms group deal with Zenzer or CloudStack. So what is CloudStack? So CloudStack is really, in a nutshell, secure multi-tenant cloud orchestration platform. What does that mean? Well, that means essentially we're here to deliver software that enables people to deploy a IaaS cloud. And today we have over 100 commercial deployments. Either it's a public cloud or private cloud. It's probably the fastest growing IaaS software out there. Not only does it control that, it has a full featured UI and user is this still working? For CloudStack, it's always been open source, but now it's actually an Apache license. It's currently incubating in Apache right now. What that means is when we donate to Apache, you're not a top-level project within the Apache Foundation. Top-level project today is something like Tomcat or web server or Hadoop. CloudStack is in what we call incubator or incubating, and so during that time, we will clean up the software to comply against the Apache rules, such as Ruby, or any GPL license, or any of the current licenses that do not follow rules of Apache. And since 2009 is when the very first cloud was launched with CloudStack. In terms of CloudStack, also one of the things that we pride ourselves as being hypervisor agnostic. So today we support VMware, KVM, OVM, Zen server, and even bare metal installation. So we support a multitude of hypervisors, even though we offer multiple network customization topologies to fit your needs as well. Multiple storage options, and we have customers ranging from tens to hundreds of physical nodes to customers that are in tens of thousands of nodes today. That's using CloudStack's powerful platform. So in a nutshell, what CloudStack does is very general. This is in every single cloud orchestration software today. We manage storage, we manage compute, we manage network. Then on top of that, we layer network services that can provide to users, such as firewall, VPNs, load balancing services. And then of course, we also offer some type of image or template management. We offer a dashboard for end users. And of course, some type of account management. But on top of that, we offer a web services API. I wouldn't say it's exactly RESTful, but it's REST-like. It's very similar to Amazon's query language API. Today, we offer the inherent CloudStack API, but we also have a very good EC2 implementation as well. And so that is continuing to be evolving. And so as more CloudStack versions are released, you should see more and more EC2 functionality. Of course, we have the self-service portal. That's one of the very first things we ever built on top of CloudStack. We believe the UI is very important for a user. It makes it easier for users to come in there and essentially do self-service and provision resources on their own without someone having to do it. So this is one of the things we have. And then of course, lastly, CloudStack provides some type of usage record that can be used for any type of reporting or metering. So that, very high level, that is what CloudStack is today. So a little bit I want to talk about CloudMonkey. This is, I know he's already embarrassed 1,000 times, but he was the one that recommended this idea. So about, I don't know, a couple months ago, we had a little contest or a lot of voting about what should be the mascot for Apache CloudStack. There was probably around 30 different donations of different variations of the mascot. We picked about 16 of them that we believe would be that would represent CloudStack the best. The voting went out for, I believe, a month, and CloudMonkey is the one that won, and it's really loosely based on the Chinese fairy tale of the monkey king traveling to the west with a group of parties. So, the CloudMonkey is now officially the Apache CloudStack Desktop. And just to give you a clue of how many people are contributing now to Apache, we have over 146 companies that are actively contributing or using CloudStack. We have about 32,000 community members now. We have over 238 developers on the Apache CloudStack project today. And hopefully you guys will add more to it once this session is over today. We have hundreds of production CloudStack. A lot of it's in Japan, but we have it ranging from America to India to Japan to Asia. So there are clouds everywhere. And it ranges from public clouds to private clouds. Again, this is one for service providers, enterprises, and users, and of course, universities where you tie up and use the software as well to power their cloud. So, what I'm talking about today about CloudStack is CloudStack. It's a very powerful software. When you install it, you can almost configure it to any number of ways you want to today. It's very customizable. You can do a lot of. You can integrate with your systems. Very flexible. But so what we found today is after years of deploying clouds is that there's really you really want to deploy your clouds in certain type of workloads. So in what we call server virtualization plus workloads, this is the application that really requires high resilience, high availability, lots of backup to make sure that the application itself really is dependent on the infrastructure to ensure that the reliability and the service continues to be on. Whereas in the cloud environment, or in what's called Amazon Cloud and architectural workload, these apps are built really to assume that they're scalable. So when we go down to server virtualization workloads, typically these are things that are architected for just hundreds of hosts. When they scale up, you really scale by the number of server clusters that you want to add. Again, I talked about the application, the way that it's developed, assumes some type of reliability in the environment itself. Usually, there's in terms of network isolation, there's either none or they use VLANs to do some type of network isolation. Of course, they take advantage of bonding, multi-lane, multi-path, any type of redundant network. And then usually it's usually a proprietary memory stack. And when I talk about server virtualization plus, I usually think about vCloud or VMware. And that's where VMware does really well. And then when you look at the other side about cloud workloads, this is, again, when we talk about cloud architecture, we're talking about scaling to thousands of hosts, right? Think Amazon. When you scale, you're not scaling in clusters. You're actually scaling in data centers. So we're talking about a huge amount of scale here. The apps, of course, assumes that it fails. Typically, these apps are very, they can be stateless, but the way you develop the application is you assume that the infrastructure itself can't fail. Typically, the network isolations are done layer 3. Very common is Amazon security, which is preventing tables. And there's really no broadcast going on there. And typically, the cloud software today are open. Think Amazon, Rackspace, these guys are all deploying cloud workloads today. And what's done here? This is things like you can think about OpenStack as well. I think they're not quite there yet, but they are building a software that can help deliver these type of workloads. But what makes CloudStack unique is we can actually deploy our software, and we can do either of these two types of workloads. You can configure CloudStack to do one or the other, or both at the same time. So quickly over there, just to summarize, what you can install CloudStack for is you can install it for private clouds. You can install it for hosted enterprise clouds. This is your managed service clouds typically. And then, of course, your very public cloud right here, which is your Amazon cloud. So any of these type of clouds you want to install for a CloudStack cloud, you can certainly do it with software today. So quickly, I want to talk about what's going to happen in terms of physical infrastructure when you do decide to install something like the traditional server plus model. So in the traditional style data center zone that you would create here, what you typically with it, you would go through using VLANs. And the type of network services we use would be some type of load balancer. Again, of course, for the apps we use would be, would require some type of multi-tier VLANs, or you can use this technology to deploy your applications. So here on the left, so this is kind of how you would design a typical server plus workload. So now, if you want to create more of a cloud-like or Amazon-like zone, the hypervisor we use today, even though it's an event server, you can certainly use KVM as well. There's usually the cheaper hypervisor. In terms of storage, you can use local storage. You can use shared storage, like elastic block storage. And in terms of networking, typically they're at the layer 3 level, like security groups, IP tables. You can also use the newer SDN layer 2 approach, and of course, some type of elastic IP support as well. And this just goes along with some of the network services that you would typically have when you launch a Amazon-like cloud. And then lastly, the applications you do today are typically managed by something like a Rightfield and Stratus, where they would deploy your multi-tier application for you, or you can use something like Amazon's CloudFormation to deploy multiple apps. And then, of course, lastly, in terms of cloud storage, you can also use some of the object storage solution as well. So this is kind of showing you differences between when you deploy traditional service and when you deploy a traditional zone and an Amazon-like zone within CloudStack. So there, again, I just wanted to show you the differences in the way you deploy. And you can see from here that when we talk about scaling up, we're talking about large quantity of hosts. So as I move on, I want to kind of quickly give you. So this is really the high level, 10,000 foot level. I want to kind of explain to you the individual level now how you can deploy this over CloudStack. So when you configure CloudStack today, of course, the very smallest unit we have today is a host. A host is really your compute unit. Let's say for hypervisor, this is either your ESXi, Z certification. And then from then on, what you can do is you can create multiple of these hosts to create a cluster out of it. And a cluster really is one or more of these hosts. And typically some type of storage that's attached to this cluster. As you move on to developing out the zone itself, you can configure them into what we call a pod. A pod is really, if I want to represent a pod, it can really be either a rack with a switch, a layer 2 switch on the top, blades of compute nodes and storage on the bottom, or it's really a broadcast domain in terms of networking. And so you can configure multiple hosts, multiple clusters can belong to pods within CloudStack. And of course, multiple pods now become what we call availability zone. And within each availability zone today, there would be a thing that we call a secondary storage. And what that does is the difference between primary and secondary is primary storage is where you store the data disk for your SVMs, whereas secondary storage is where you store all your templates, ISO, snapshots. So your primary storage is typically where you have fast storage, whereas your secondary storage is really your cheaper commodity storage, and you typically want to back this one up as well. And then on the very top of the zone, you would have some type of load balancer firewall that crosses between each of the zones. And then if you think about it, one or more of these zones really represent what a cloud is today. I briefly went through this, but again, let's recap. So primary storage here is really either it's local disk or some type of shared storage. And that's where you would put the disk volume for each of your SVMs. Within CloudStack, you also have the capability of adding multiple primary storage per cluster. So you could even have slow disks configured so that you have slow disks for one primary storage and faster disks for another. And through what we call our disk offering, we can offer to the users various ways of controlling where the disk volume can be created. So for example, I could, as a user, I could CloudStack today and say, I want a VM for MySQL. So typically the compute power doesn't matter as much to me as the really fast disk access. So the administrator of the CloudStack admin created an offering that says, it's for fast disk. And what CloudStack will do is when we create that disk volume, we'll put it onto the fast disk. Similarly, I can also say, hey, I want a VM that's just doing web server. So I don't really need fast disk, I need large compute power potentially. And I don't really care about this. And so CloudStack allows you to place where you want your disk in the primary storage. And in terms of the secondary storage, right now today is you have to have one per zone. And that's essentially where all your templates and ISO are stored at. And all snapshots are taken with CloudStack today are always copied over to the secondary storage. And right now today we support NFS. But we also have an integration with OpenStack Swift, so you can decide to use Swift instead for your secondary storage. You're certainly most welcome to do so. The difference between the two is really OpenStack Swift is more reliable since it's actually replicating itself across multiple storage. The drawback of it is it's much slower than if you were to have a straight NFS server. So in terms of what CloudStack can work, we can manage one zone, we can manage two zones, we can manage multiple zones. And this is what I want to show today. Within a single management server, you can manage zones for multiple data centers, etc. What we also do today is we also support clustering within the management server. So in case of failover, any of the other management servers can take up the work in case one fails over. And currently today, we have certified it to each management service for up to 10,000 physical nodes. Potentially even more, but that's what we have certified today. And we definitely have customers that are in that range today. So we have already proven that CloudStack can certainly scale to tens of thousands of nodes and medium. What this shows really is what we can support. Again, in a single node deployment, you would have a management server, MySQL, attached to it, and it would serve up management cloud and serve up the API. You can also have a mobile management server. What we typically recommend is two at least, just for failover in case one of them fails. And then again, CloudStack today supports multiple hypervisors, but I want to kind of spell out the little differences between each of the hypervisors that CloudStack supports today. So for XenServer, the way the management server talks to XenServer is through what we call Divve, or the XenServer API. It is a HTTP-based API. And so we communicate through XenServer all the commands to start, take snapshots, whatever commands through the XenServer web Divve API. In XenServer today, in terms of how we deal with snapshots, it's all incremental. So the very first one may be huge, but each snapshot we take after that is really the delta difference. It's the PHP format, which is something that XenServer understands. Also, XenServer supports NFS, iSCSI, fiber channel. And if you decide to do any type of storage over provisioning, which means if you do storage over provisioning right now today, it's only supported NFS. You could do an iSCSI, but typically, if you do an iSCSI, you're going to have an iSCSI vendor enable the over provisioning process itself. But with NFS, CloudStack can do it for you. So in terms of vCenter, the 5.0 says it's coming. Actually, it's already supported since 3.0. So for vCenter, for VMware, we already support ESXi 4.1 and 5.0. In terms of snapshots, it's different. It's full snapshots today. We are working on trying to see if we can do incremental snapshots in the future. But unfortunately today, each snapshot we take in VMware is going to be a complete full clone of the VM itself. In terms of the storage, it uses very simple to XenServer, NFS, iSCSI. And then in terms of storage over provisioning, because it has the NFS, you can actually over provision both either NFS or iSCSI. In terms of, the way we talk to VMware is through vCenter. So you have to have vCenter, and we use their HTTP API to communicate directly with vCenter and then to the rest of the ESXi hosts. We do not talk to ESXi hosts directly. One of the reasons why we did choose to go that route instead of individual ESXi's is because we believe that anyone that's using VMware today probably has vCenter, and you do lose a lot of functionality if you don't have vCenter, you don't have migration, live migration, etc. So we decided that the best way to communicate vCenter today is through vCenter. In terms of KVM that we support today, the difference between KVM is KVM itself is not offering any type of remote API. It does offer a libvirt. And so what we do is you have to install on each KVM host a Java agent that we've built. And that itself will communicate via our own CloudStack proprietary protocol between the management server and the agent. The agent itself will communicate via KVM via libvirt. It already supports up to 62. I know this code is a little bit old. Again, in terms of snapshots, it does not take incremental snapshots. It takes full snapshot just like VMware. In terms of the storage, very similar to Z-Server ESX as well. And in terms of overall provisioning, it only supports ZFS right now. And lastly, we also have OVM support, and I believe it's up to OVM 2.3. Unfortunately, with OVM, we have the least amount of support right now. We only have snapshots, and there's not any type of storage or provisioning at all. Before I get into networking deep dive, again, I want to make this something where it's really for you. So if you have any questions right now, I'd be more than happy to answer it. You get the free T-shirt. The question is good. Anyone? Okay, no one wants free T-shirt. That's all right. Oh wait, actually, hold on.
You have to have T-shirts.
Hypervisorの警備なんですけども、EL は、
ちょっと待って、Are you guys on?
Or should I ask in English?
If you can do English, and
Okay, so for the in terms of the hypervisor, for the KVM, Red Hat was mentioned, but do you have like Ubuntu or some other distribution?
yes, I did mention with Red Hat, but yeah, we have our team have played with Ubuntu, so Ubuntu should be certified. I didn't use this inside, but it should be. Yeah, and I think we may have only tested up to 10.04 LTS, so I'm not sure or any of the other future versions. But I believe at least 10.04 LTS is supported. Good question. I don't know who's going to give me the T-shirt, but I'll remember that. Anyone else? Question? Okay. So I'm going to let this run, but the one really powerful tool with CloudStack is the flexibility it allows when you configure CloudStack and deploy an environment. It does allow a lot of flexibility in terms of how you configure your network. So for example, the network services that we do offer are NAT, and load balancer. I'm not going to go through all of these. You should look see it. In terms of the providers of these network services, we do our own virtual. We can also do hardware. For example, a load balancer, it can be done through our virtual router. You can also replace it. That can be done using Citrix NetScaler or F5. In terms of firewall services, we could probably use, again, our virtual router to do the exact same thing, use a guided table rules, or we could use SRX. And the way the architecture is done is you essentially add new hardware appliances in the future as well. So Brocade or Cisco, and I do know they have some implementation. So if they want to offer their own what we call network service providers, they can easily add that to CloudStack today as well. And then in terms of the network isolation that we have today, and I'll go through it again, how we isolate between guest network. We offer none. You can either use VLANs. We also have a tech preview of Open vSwitch only on Zen server today. And of course, layer 3 isolation and security. So the first thing I want to talk about is in terms of network or guest isolation, what do we do in the layer 3 model? So this is exactly what Amazon does today. It allows you to create what we call security groups. Since essentially IP table rules that configure the traffic going in and out of firewall multiple guests, multiple security groups. So if you ever play with Amazon security, this is exactly the same thing. So what I want to mention on the left side is that you can configure CloudStack to use security groups. But if you want any type of network services like load balancer, that's something that whoever's installed CloudStack would have to do themselves. So we don't manage it. Alternatively, you could actually put a NetScale load balancer here and using this type of network, and now you can offer EIP ELB support. And so in this case, we will actually program NetScale for you. So very similar, you have security groups, but if you stand in NetScale in front of it, you can effectively get the EIP ELB support. I'm going to drink some water. What's in the bag? So in terms of the layer 2 guest network model, on the left side, the way we isolate guest traffic is now through using VLANs. So each virtual network, each network that's created, we assign a VLAN to each of the network, and so that isolates the guest traffic from one account to another. And this left side here, what it shows is this virtual router that CloudStack launches bridges between the public network and inside the guest network itself. This is the VLAN now. And that virtual router can provide all the network services: load balancer, VPN, site-to-site VPN, DHCP. On the right side here, since 3.0, what we've given the opportunity is for someone to plug in additional hardware appliance. So for example, if you wanted to replace load balancing, right? So for, as someone that's using the cloud, I can launch my service and say, this is a very small web service today. I don't know how much it can grow, but I can certainly just use the virtual router with software. It meets my need. But let's say my service is growth. Now I know that it can't support the type of traffic that I'm getting. Now the administrator can give the capability of now having fronting of the NetScaler or F5 instead. And so by using hardware appliance, which should technically be a lot more efficient than just the software. And what 3.0 gives you is the opportunity for the administrator to offer things like what we call network offering. So network offering. So what you can do is very similar to service and disk offering today. So the service offering is very similar to Amazon's EC2 or Amazon Large. It defines the size of the VM itself. Disk offering really defines how big the disk is and where, if you wanted to use different types of disks, maybe a large SAN or whatever. And then the network offering today, very similar. So now you can go and create one network offering as I want to front it with just the virtual router for my load balancing or firewall. And I can control some type of network rate. And I can offer this as with one price point. Then in the background, I can also configure a different network that offers, instead of virtual router for load balancer or firewall, I can front it with an SRX or NetScaler. And if I choose to create my VM in this network, it'll offer the hardware appliance instead. And the great thing about Since 3.0 is that the user can actually upgrade and downgrade between this network. So for example, if I wanted to switch between the virtual router to a physical NetScaler load balancer, CloudStack will copy all the rules right into that physical load balancer, so that the user may see a little delay while this copy happens, but you don't have to recreate the entire network again. You don't have to recreate it because CloudStack will seamlessly copy all the rules over to the hardware load balancer and the user. Everything is just as it is, except it's just a lot faster. So that's what we've introduced since 3.0. If you have used the 2.2, you couldn't do this before. You had to predetermine. You had to create these network services one time, and it's for the entire cloud. Everyone chooses that. You don't even have the opportunity to select back and forth between virtual router or a physical load balancer. And the things that you can do here is, of course, you can control network rates as well. You can control the type of services that you want to offer. You may only want to offer load balancer. You may not want to offer anything else. For each of the services that you offer, you can select what you want as a provider. It could be the virtual router itself, or you can put in a F5 or physical appliance as well. And of course, all the offerings that we offer in CloudStack today, you are given the opportunity to select who can see it. So you can make it public, everyone can see it. You can specify that only a domain can see it. Or you could go all the way down to individual account level and say, hey, for this account, you're special. You can create your use this same account. And then the last thing you can do is, since 3.0, we have enabled redundant router, where if you've ever looked at the 2.2x CloudStack, there's only one virtual router that sits between the public and the private network. If that thing goes down, that's it. You're pretty much not going to be able to access your network from then on. So we offer, since 3.0, you can actually enable the redundant router feature, which means that it's actually an active passive setup. So one router will be running. If that's detected to be down, the other router will kick in, take over the network services. Again, you may have a little lag time while it's being brought up. And the CloudStack itself will clean up the original one and launch a backup to the one that just been running. But it gives you more flexibility or more redundancy in terms of the virtual router support. But again, the very most important thing is in the network offering, you give you the opportunity or the user to upgrade and downgrade the services. So just like you can do with your compute nodes, if I pay 16 gigs of RAM to the 4 core and decide it's too big, I can downgrade it. Or if I think it's too small, I can upgrade that VM. I don't have to do anything else. Same for network as well. You have the opportunity to change that. One of the networking that's going to come out in what we call a Burbank release in the Citrix platform, and we're also going to put this in Apache CloudStack, is the notion of multi-tier networking. And so what that does is, today in CloudStack, you can create one network. You can specify the rules of the traffic coming in through the virtual router, but it's always for one network. When Burbank releases, which I believe should be in August of this year, you will be given the opportunity to create multiple networks. And through that same virtual router, that acts as your main gateway for traffic, but that can control rules from one network, from let's say your web tier to your app tier, to your database tier. This is your typical 3-tier networking. And so now you can control inputs and outputs, or the access rules between each of these networks now. So you couldn't do that before. Now you can do that with the multi-tier feature. So for example, what I could do is I could say that the public network can only access any of the VMs that's in the web tier. I can also program to say that the web tier can only access specific ports in the app tier, but nothing else. Can't go to the database similarly back and forth. You can specify a specific rule. So how do you want each network to access each other? So that's actually come out in the Burbank release, which is in August. Other things that you can do with multi-tier networking is you can now store all the VMs at the same time. So you couldn't do that before. So you can say for this entire group, launch all the VMs or destroy all the VMs. So after Burbank, you will you have the capability of doing groups of VMs or tiers of VMs simultaneously. It's going to start on. We're going to be adding a lot more of these features as we go on. But this is just to give you a quick preview of what we have. Okay, so before I go into the current software architecture, any quick questions? Networking? Yes. No. I have to turn this on. I don't like it. What I don't like it.
渡したやつがすみません。
クラウドで SDL ってすごく重要なファクターだと思うんですけど、それに対してのたったオープンフローに対応するということだけではなくて、どういうふうな格好でクラウドスタックで今後はアプローチしていくのかというのをちょっと聞きたいんです。
So I'm not the one that actually wrote the SDN stuff, but in 3.03 CloudStack Cloud Platform, we already have a tech preview on the implementation of OpenVSwitch on Zen server, unfortunately. I don't have much more into it, but we do intend to make SDN a very important part of CloudStack. Yi, who is actually the network architect that works on all the SDN architecture, is probably better to ask this question. But rest assured that SDN is something that's very, very important to the concept. But for right now, if you actually want to play with OpenVSwitch OpenFlow, it only is on CloudStack 3.03 and Sensor only. So we are working on KVM, and I believe KVM, but I'm not sure about VM right now. Is that good enough?
多分一つずつのファクターはそうなんですけども、全体的な構想として、SDL を例えば、クラウドスタックの一つの技術の現状では大体分かっているんですけども、商売としてそういうネットワークのコントロールっていうのがオープンクラウドスタックの中でやっぱり主流でちゃんとやっていくつもりなのが。そこは単純にその技術に追求していくのかということを
Actually, it's a good question because Shane is going to talk about the future of CloudStack architecture. He can actually have more insight to how we plan to make sure that networking is definitely CloudStack. So I agree with you. I believe with Shane and Charity working, this is something that we will be leading the effort in, rather than something that we just want to play along integrated prototype. So Shane actually will talk a lot about what we believe. There's a lot of work that and a lot of issues that we see CloudStack architecture today. It's not just networking. Networking is definitely one of them. But we want to make sure that CloudStack in the future is capable of allowing people to, integrate new technologies a lot easier, and then expose it to the CloudStack user. And so in a little while, Shane will probably discuss a little bit more about how we plan to do that. Thank you. Stay here. Any other questions?
Thank you very much. It's fantastic that CloudStack can support network offerings that is independent of the actual implementation of each vendor. So when, for example, when I have to add our own network services for example, firewall or other newer routers, then is it quite easy in current implementation? In other words, do we have a plan to create some API or some sort of abstraction layer to support multiple network offerings devices?
So when you mean network server, let's take for example, let's say firewall. Do you mean that how easy to have SRX or Cisco share? Okay, so that actually is already there today. This is why we have just take firewall, load balancer, because we have one. But for example, load balancer itself, we have 3 different types of service providers. We have the virtual router today, using HA proxy. We also have SRX, and we also have NetScaler and F5. If you want to add a 4th load balancer hardware appliance, it's very easy. It should be very easy today. We already have in the Java, there's already a predefined API that you would have to extend and just implement each of those APIs. And what you would do is you really only have to implement the communication layer between Java and whatever external API is. So the piece that you're writing there is very stateless. It's really a translation layer. For example, the load balancer rule may say create port 80, load balance port 80 to these various mediums. All you have to do is translate that to the native API for each of the hardware devices. And that's that usually is being handled. I mean, you can certainly look at the reference implementation of NetScaler and F5.
That's good. Thank you very much.
It's not, I would say it's one more runtime, because I think what you would have to do is to write your Java code, create jar file, drop it into the CloudStack, wherever the class path is, and then configure it within what we call components.xml. There's a configuration file that you can specify for each of these services, what network provider you put in. But it's not runtime. I don't think you can just drop it right there and assume the words. I